Hello and welcome to Friday STEAM with the Warren County Library System. My name is Sandy Roberts and I am the Makerspace Coordinator. Oops, and I have frozen. Great. We're having a heck of a day. Sorry, my camera seems to have frozen. Give me a moment to turn it off and turn it back on again. Hopefully that has worked. All right, hey, let's try this again. In theory, it's always something. Okay, let's see if that works. All right, let's try that a second time. Hello and welcome to Friday STEAM with the Warren County Library System. My name is Sandy Roberts and I'm the Makerspace Coordinator with the library. Normally I'd be in the Makerspace over at Southwest, but as you know, right now we can't be open, so every week I'm bringing you science, technology, engineering, art, and math online at 3 p.m. every Friday. We have been learning about the states of matter the last couple of weeks, and we're going to continue that this week as we learn about gases. And then we're going to take a break for Thanksgiving, and we'll be back in December with a presentation on non-Newtonian fluids, which basically covers all the other types of states of matter that we can find on Earth. We'll also talk about Bose constants, we'll talk about plasma, you know, all those kinds of really interesting things, and I've got some more experiments for you. But today, it's all about gases. So let me go over the supplies you're going to need for our experiments at the end, and then I'm going to talk a little bit about the science behind everything. And then we'll do a couple of experiments together. As a reminder, I've got my cell phone, so if you have any questions at any point, feel free to just go ahead and ask. I will pay attention and make sure that I do my best to answer those in the comments. So our supplies for today. Oh, 1 second. Okay. We have 2 experiments that we'll be doing today. So for our first, we are going to need a disposable water bottle. You'll need a funnel, or the easiest way to make a funnel, in my personal opinion, is to cut the top off of another disposable water bottle. And the nice thing is you can recycle both of them when you're done with this. You will need some vinegar and some baking soda, because I'm going to prove to you that gases take up space today. And you're going to need a balloon, at least 1 balloon. In fact, you're going to need 2. Because our second experiment, we're going to be making a barometer, which is a weather device that helps you measure air pressure. Because air pressure can affect whether or not thunderstorms are coming in, how weather systems change. So a lot of folks that pay attention to the weather look for high and low pressure, which will tell you if it's going to be a nice sunny day out or potentially a stormy day. So we're going to talk about that. For that experiment, you're going to need a glass jar. This is about 2 cups. You're going to need another balloon. You're going to need a straw. And you're going to need a pair of scissors, which I have misplaced, but we'll find in a moment. Okay. Like I said, it's been kind of one of those days. You're also going to want maybe a rubber band, okay, and a bit of tape. So those are our supplies for today's projects. Okie dokies. Let's get to the science, and maybe you or your mom or your dad can gather up some supplies, or maybe an older brother or sister, while we chat a little bit. Okay, I'm going to switch to my presentation. Alrighty, so we're going to do a quick review of some material that we've talked about already. So some of it might be a review to you. I'm going to go through it pretty quick because we've got kind of more experiments to do today. Our first discussion, of course, if we're going to talk about matter, we need to talk about atoms and molecules. So atoms are your building blocks of everything. You can think of them almost like Legos, right? You have lots of different types of Legos probably, and each Lego is a little different. Same thing with atoms. Every atom is a little different. And just like every Lego can be used in a little different way, every atom has its own properties and characteristics. You're different from your brother, your sister, your mom, your dad, your grandma, your friends. Well, every atom's different too. We have about 120 different elements. Elements just mean something made up of only one type of atom. So some elements you might know are oxygen, hydrogen, helium, nitrogen, carbon, So there are like neon, there are lots of them. Silver, gold, all of those are elements, okay? And they're basically the smallest bit of matter that you can possibly have. Now, if you take multiple elements and put them together and react them, like we're going to do today, we're going to do a reaction today, you can make new molecules, okay? And you can make millions of different molecules. Here's the thing. When you put two atoms together, the characteristics of those molecules could be totally different. For example, mom and dad, maybe they both like, I don't know, pepperoni on their pizza, but you don't. They made you. You're a combination of the two of them, but you like something different on your pizza. I don't know, maybe you like broccoli. I do. So when you make a molecule, often that molecule will be very different from the elements that went into it. For example, one of my favorites, if you take sodium, very reactive metal that can actually explode when you put it in water, and chlorine, which is a gas, a poisonous gas, okay? You take exploding metal, poisonous gas, put them together, you get salt that you can sprinkle on your French fries. Perfectly harmless stuff. Tasty too. So this basically happens because if you noticed in my last picture, we have a nucleus where we have our positively charged protons and our neutral, no charge neutrons, which work like packing peanuts to keep the protons from coming too close to each other. And then in a big cloud around that nucleus, we have these tiny, super fast moving electrons. Well, sometimes electrons like to travel, okay? So if two atoms decide to share an electron, or if one atom steals an electron from another atom, we have a bond that's made, okay? And when that happens, we get a molecule. These compounds can then join together. Molecules can join together and become macromolecules. And compounds are just molecules made from lots of different elements. And often we'll refer to it when even those molecules have now joined together and become a bigger molecule. That's a compound. Millions of different ones. And all the food we eat, all the chemicals we use, all the clothes we wear are made of different compounds. Gases included. In fact, our air, okay, is a big mixture. A mixture is a little different from a compound. In a mixture, there's no chemical reaction that's going on. You just, if you take everything and you want to make a salad and you throw it in a bowl, you have a mixture, okay? If you take everything for a cake and you bake it, now you have a reaction. Now you have a compound. You've made something new. They've reacted together. So our air is a mixture. They're not chemically reacting, but we have nitrogen and oxygen and carbon dioxide, all kinds of elements and molecules floating around in our air. Now, states of matter. I mentioned we've studied liquids, we've studied solids, now we're studying gases, right? These are all our states of matter, and matter is basically anything that you can touch, okay? It's anything that is around you. Basically, the universe is made up of matter and energy. Matter is what you're made out of. Atoms, compounds, molecules, they're what make up matter. Pretty simple. All matter has mass, okay? It weighs something, and it takes up space. It has volume. And that goes for gases too, and we forget that sometimes. Gases have mass too. So, mass is the amount of matter in an object, and it changes, okay, depending on the amount of gravity pulling on it. So your mass here on Earth is different than the mass you might have, or no, your mass here on Earth is the same. Your weight on the moon would be different because there's a different amount of gravity pulling on you. Your mass depends on how many actual atoms are in you. That's not going to change too much. But your weight is a little different. That's really a force, how much gravity is pulling on you because of your mass. Sometimes we use them back and forth, and as long as everything you're talking about is here on Earth, it's not a big deal. But I just wanted to make sure that we point that out. So keep in mind that gases do have mass. We forget that sometimes because we can't really see them usually, and they're so often lightweight, there's so little mass that we tend to take them for granted. But if you've ever seen a balloon filled with helium, you've seen that different gases have different masses. So air has more mass than helium in the balloon, which is why the balloon rises. Okay? It rises above, kind of like the oil in a salad dressing. It rises above the water because it has less density and less mass. So it's important to remember, gases do have mass. They weigh something. They also take up space. We forget about this because gases spread out to fill all available space, and they can fill a lot of space, okay? Unlike liquids, which tend to fill, you could fill a jar with liquid, we'll be doing that, but gravity pulls it to the bottom of that jar. Gases aren't really, affected by gravity as much because they have so much less mass. So that basically means that a gas can take up an awful lot of volume unless you capture it in something. For example, like a balloon, okay? And that's what we're going to be doing. All right, our states of matter, of course, we tend to think of solid, liquid, gases, but there are also plasmas, non-Newtonian fluids, etc. Basically 5 we've identified so far in the universe. There could be others, okay? There could be others. All gases can change their state. All matter can change its state. So it can go from being a solid, which tends to be hard and rigid or brittle. It tends to take up a very specific amount of space. Like if you look at my picture here, a solid, an ice cube. You could think of it that way. A liquid tends to take up more space. It can fill a container. But again, gravity's pulling it down, so it fills the bottom of that container. A gas can take up more space. It can float. It has less mass. And it can fill that whole container, not just the bottom. So liquids are very fluidy and gases can move around everywhere. Gases can also carry tiny particles on them. So if a particle of liquid, for example, is really small, gases can actually float around carrying that. And that's why we smell odors, good or bad. And that's why we have to be careful of germs like coronavirus or the flu, because those tiny particles of, I know this is gross, but the tiny particles of our own spit can actually float around on the gas. The gas will travel with them, will carry them. So, we forget about that sometimes because, again, we can't see it. But it doesn't mean it isn't there, and it doesn't mean it doesn't exist. Now, when a matter wants to change from one state to another, it goes through a physical change. And again, this isn't a chemical reaction of any kind. Nothing changes about the matter. Water is still water, whether it's an ice cube, a glass of water, or water vapor. It's still water, okay? And basically, when you get energy into your matter, that's when it's going to change its state. Okay? So when an ice cube gets warm, it melts. When that water is heated up a lot, it starts to boil and evaporate. And the same thing, once that water vapor rises far into the air as a cloud, it gets cold and it condenses. And eventually, if it comes back down to Earth on a particularly cold winter day like we're going to start having soon, it will freeze. What's important to notice is that the temperature for melting and freezing are basically two sides of the same coin. It's the same temperature. Same thing with boiling and condensation. It's the same temperature. Now, I will mention today, I haven't mentioned before, but you see sublimation and deposition on very rare occasions. A solid will sublimate. It will skip over becoming a liquid and jump straight to being a gas. If you've ever seen something like dry ice, this is an example of carbon dioxide, which has been made super cold and put under a lot of pressure to force it to become, to deposit into a big cube of essentially ice. But when you bring that out into room temperature, it quickly turns back into a gas without that pressure and that cold. This is important, okay? It's a special trait that gases have, that they're able to be put under that kind of pressure and temperature change and very rapidly change states. And that's because there's so much space and so much energy in a gas. Okay, let's get on to learning a little about gases specifically. All right, molecules and gases, as I pointed out, spread out. They're really full of energy. They're constantly bouncing off each other. That's why when you add your own breath to a balloon, those little molecules of air inside the balloon are bouncing so hard against the inside of that balloon that they're literally pressing it out. They're creating the pressure in there. Gas molecules have a lot of energy. They're bouncing around everywhere. They're constantly in motion. Whereas a solid, they're kind of just vibrating a little, Molecules and gases are moving. They have lots of energy. So gases can fill any container, any size, any shape. And it doesn't matter how big the container is. You may not think about it too often, but our Earth has a container that holds all of the gases on our planet. It's called the atmosphere. Okay? And it holds our air, our water vapor, and all of those important things on our planet. Planets that don't have an atmosphere, or moons that don't have an atmosphere, can't have oceans because they can't hold the water vapor close to the surface so that the water cycle can continue. They can't breathe. You know, a creature couldn't breathe on that planet because there's nothing holding the atmosphere, holding that air as a little bubble next to the planet. One of the reasons our planet is so special is because we have that atmosphere. Okay? And that has to do with holding those very precious gases against the surface of our planet. All right. I mentioned pressure. Okay? Gases hold lots of energy. I know I keep saying this. And their molecules like to spread out. But when you put those gases under pressure, like you can see in this picture, here the gases all spread out. But if you put it under pressure, you can condense it. Now, there are a lot of ways you can condense gases. Again, if you take the energy away from them by making them cold, they're going to slow down and eventually condense. But if you take that energy away from them and make them cold and also press on them and put them under pressure and take the same mass, okay, the same mass of gas, but put it in less space, less volume, it's going to become more dense and it's going to often start to condense or have other traits. And this is what I meant about the weather, okay? When we see pressure changes and the pressure suddenly drops, that usually means there's cold air coming in, okay? And that often means there's a big change up and we're going to have some kind of a storm. All right, vapor. You may hear the term vapor sometimes used for gases, and you can basically use the two interchangeably, but technically, vapor means a gas that's usually that is usually a liquid at a room temperature. So water. We don't say water gas, we say water vapor, because usually when we're just hanging out, water is a liquid. Mercury is a liquid. Grape juice is a liquid. So if you were to heat them up enough to evaporate, we would call it grape juice vapor. Okay? But things that are normally a gas at room temperature, like carbon dioxide or oxygen or helium, we just refer to those as gases. We don't refer to those as vapors. It's a tiny little word thing. Science is full of them. But I wanted to point it out just in case you ever see that terminology and were confused. Okay, so that was a whole lot to throw at you. But if you want to learn more, here are some good websites to do that. The first is Chem for Kids. Okay, I really like this website. I've used it many years as a teacher. I think it's got good basic resources, it's a good starting point, and it's visually attractive. Okay, and is laid out really well, so you can get has a good table of contents, so you can find exactly what you're looking for. Now, if you like videos, Crash Course Kids has a whole playlist right here that you can go to, and they will answer all kinds of questions about matter and atoms and all kinds of stuff. And they're, again, short, fun videos. They've got some music, great host, really good videos. I like them. And then, of course, check the library catalog, both on Hoopla and Cloud Library. If you want digital resources you can download immediately, or our catalog on warrenlib.org. We've got lots of books on science for you. Okay, so you can check those out. You might even want to check out something like Flipster, Scientific American, Discovery, National Geographic. These all have great scientific articles too. Popular Science, all magazines that you can borrow for free digitally through the library. So we have lots of resources. Okay, so that's our science presentation for the day. Let's move on to our experiments. I'm going to switch my camera here. Alrighty. Oh, and it's frozen too. Why is everything freezing on me? Let me fix this, my friends. I'm so sorry. I'm just having all kinds of issues today. Okay, that's better. And fixing this one. What are you gonna do, right? Did that work? Try it again. Come on, camera. This works a lot better if I can show them what I'm doing. Oh, I know. Every teacher out there is going, yep, I know exactly how you feel right now. Oh, look, that's me upside down. That's funny. Okay, I really don't know what's going on right now. Let's see. Okay, I do not understand why this is not coming through. Especially because if one is coming through, the other should be. It's on the same cable. Yeah. No idea. Okay, I'm going to do the whole unplug it and plug it in again and hope that that does the trick. Okay. Please. Nope. Okay, so now we do the unplug. I am so sorry, my friends. This was all working. I tested it all before I went live. And, you know, sometimes even when you test, things don't go quite as expected. And it's showing up on my camera, so I do not understand why it's not showing up here. And we're going to try one last time, and then we'll just come up with a different way of doing this. I am thinking of moving to recorded video for this reason. Can you imagine? I can't imagine why. All right. We will try and do it this way and hope for the best. What are you going to do? I always have a backup plan. Many years as a teacher, you got to have a backup plan. Give me just a second to see if I can move things around a little bit so that I can have some space to do this. Forgive me. This is the fun of going live, right? Okay. Well, I think I've kind of got stuff out of the way. 1 second. Just going to get a tray to raise this up. And okay. Here we go. And I'm getting all this weird blinking too, so that's exciting. Not sure why that is happening all of a sudden. Hopefully we'll make it through the rest of the podcast, right? Or the video. All right. So we've got our disposable water bottle. And we're just going to go ahead and add about 1 inch or 2 of vinegar to it. And I'm going to go ahead and use my handy little funnel. This is hard to do because I'm just using a box to put it all on. So let's hope this works out. It's making a mess. I kind of figured that might happen. All right. Because this is not kind of how I wanted to do things. All right. There we go. So a couple of inches of vinegar in the bottom there. Just clean up the spill. Okay. Okie dokies. Okie dokie. Now, we're going to take our balloon, and what I'm going to do is I'm just going to attach it to my little funnel here, because I want to put baking soda into my balloon. So I'm just going to go ahead and add my baking soda. Where is the little tab thingy? Here it is. Okay. And this takes a little bit of effort, but it's worth doing. So you want to put, a couple tablespoons into your balloon. You just kind of stretch your balloon out to get it to fall in there. And you can kind of use your finger to wiggle it in. I hope that you guys can see this okay. And you can see I'm really putting quite a bit in there. So you want to put a couple tablespoons in there because we want to... I'm ready for the weekend. How about you? All right. Now that I've got a mess everywhere, got my balloon. I'm going to take it. I'm going to stretch it over the neck of my bottle and then shake. And there you go. So what's happening here is we have a chemical reaction going on. And you notice I'm holding the neck of the balloon onto my bottle. So when baking soda and vinegar react, this is not a physical change, this is a chemical change. When they react, they make a gas called carbon dioxide. Okay, and that pushed what air was left in the bottle up into the balloon, and then all the carbon dioxide that was made filled the balloon. As a reminder that gases take up space. So there we go. This is really fun if you want to do, if you like The Grinch Who Stole Christmas, if you draw a heart on this and then let it blow up, it's a really fun activity because, you know, his heart grows 3 sizes bigger. So I enjoy doing that for Christmas, for those that celebrate. Okay. Whew. Now I've got, again, a mess here. We're just rolling with it because sometimes you have to. Okay. This is great. I've got another class after this too, and I'm not even going to have time to clean up. Fun. Okay. Oh, gosh. Okay. Now, our next one, a barometer. The way that this works is we're going to trap air inside our glass jar, okay? And we're going to cover it with a balloon, and we're going to use a piece of straw. When the pressure inside the jar increases, the straw is going to get pointed up a little bit. When the pressure decreases, it's going to go down. And basically, this is relying on the air pressure inside the jar to be acted upon by the air pressure outside the jar. So when the air pressure outside the jar is high, it's going to push down on the jar and up goes your needle. When it's low, the jar is going to expand a little bit and down goes your needle. Okay? And you can calibrate your barometer by checking what the air pressure is for a couple of days and putting a white piece of paper behind your barometer and just marking those different pressures. Pressures are usually measured in either atmospheres, you know, is it equal to our atmosphere or a little low or high, or in millimeters of hydrogen, or mercury rather, because the first barometers were made with the liquid mercury inside a thin tube. You can still buy those, but you have to be very careful because mercury can be quite dangerous. So we're going to start by taking our balloon, and we're just going to cut off the neck like that. Okay, and now we're going to stretch it over our jar carefully so we don't snap our fingers like that. Okay. And I'm just going to grab a rubber band to help make sure that it stays secure. Okay, easy. Now I'm going to take my straw. I'm going to cut off the flexy bit. Don't want that. Okay, and then, and I wish I could show you this a little more clearly, but I'm going to cut kind of a triangular shape, a point, to make my straw have kind of a point to it. I'm just going to cut off the back part of it because I only need one. So I have kind of an arrow. And then I'm going to lay that right on my balloon and take a little bit of tape. And of course, I would have picked the worst possible masking tape I had that is not working right because it's that kind of a day. That's okay. I've got a nice weekend coming up. Spend some time with my family. That'll be nice. Okay. Well, my tape is not working for me, but you get the idea. You're going to put a little bit of tape, transparent tape, masking tape, duct tape if you really want to. I usually use transparent for this. Aha, got some. So you're just going to tape it on there. Okay, and you want to make sure this is level. Whoop. You want to make sure that your point is facing sideways. And there you go. That is your easy to make barometer. And when the pressure goes up, up goes your pointer. And the pressure goes down, down goes your pointer. Now, it won't be that dramatic. So that's why it's really useful to put a piece of paper behind it, mark it, and write, like, this is what the pressure was that day. But this will eventually, once you calibrate it and get used to it, it'll warn you when a storm is coming. You'll know when a snow day is happening the night before. If you want more weather items, this book has a bunch of ideas in it. The Big Book of Maker Camp Projects. I know that there are lots of good ideas in there. I wrote the book. So you can get that at the library. And it's got a whole section on making weather instruments, which is really fun. Okay, I think I've made enough of a mess today. My camera is clearly giving me trouble, so I think we're going to call it quits. My name is Sandy Roberts. I'm the Makerspace Coordinator for the Warren County Library System. You can join me every Friday at 3 p.m. for Friday STEAM, where we'll explore science, technology, engineering, art, and math, and learn a little something new. Check out our calendar at warrenlib.org for all of the upcoming events, not just my own. We've got lots of fantastic things planned, including on Monday, actually, is a great presentation called Lincoln and Thanksgiving. And we have a historian and Abraham Lincoln impersonator who's going to come and tell us all about how the holiday of Thanksgiving came to be in America. So it's great for ages 6 and up. Fun program. Definitely check that one out. All right. Take care, stay safe, stay healthy, and have a wonderful Thanksgiving next week. I will see you soon.